Hello all, welcome to Unacademy. Today we will going to see our next lecture on discrete mathematics. Okay, in this lecture we will see how to how to solve the examples on functions. Okay, we will see the different types of functions, definition of functions, and different types of functions, and the example based on that different types of functions also. Okay, before going to start this, let me introduce myself. Myself, Dhanashree Mam. I completed my MSc in mathematics from Mumbai University, and I'm also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Okay. Now, before going to start this, let me tell you how to install the Unacademy's Learning app. First, go to your mobile's Play Store app, then search Unacademy's Learning app, and then install the Unacademy's Learning app. After that, you will manage your goal. जैसे कि हम लोग यहाँ पे गेट एंड ईएसी के लिए पढ़ रहे हैं अभी, so you can manage your goal. जो भी एग्जाम आप देना चाहते हैं उस एग्जाम के लिए आप यहाँ पे मैनेज कर सकते हो. So you can use a goal like GATE and ESE. हम लोग यहाँ पे अभी GATE and ESE के लिए पढ़ रहे हैं. So you can we are managed here GATE and ESE. Then you can take any subscription plan either for pre-subscription, plus class subscription, special classes, whatever you want. You can choose your subscription plan and then press the get subscription button so that you will get the subscription of that respective goals and course. Okay, now then after that I will suggest you, if you are going to prepare for the GATE 2022 or 2023, then I will suggest you can take a subscription plan for 24 months so that it will be clear your whole study in this 24 months plan. And for that you can use my promo code, that is DSP here. So you can use the promo code DSP to get the 10% discount on your subscription plan. Okay. Now next is, here you can use your payment method either for debit card, credit card, or UPI or EMI wallets, anything you can choose your payment method for the to get the subscription plan. Okay, and the most important thing, if you want to unlock the free plan of Unacademy, that is for special class, for live test series, for quiz and Unacademy combat, you can use my promo code DSP to get the free unlock plan, or to unlock the free plan of the Unacademy. You can use my promo code, that is DSP, so that you will have these benefits: special classes, live test series, quiz and Unacademy combat also. Okay. Next is, now we will going to start our actual topic, that is our functions or mappings. Okay, first of all we will see what you mean by function and what you mean by mapping. Okay, so we will start our actual topic, that is functions or mappings. Okay, now see here, let A be the set of 40 chairs. We will elaborate the definition with the help of this example. Now see, suppose let A be the set of 40 chairs in a classroom and B be the set of 30 students, right? There are 40 chairs and 30 students. The correspondence between set A and set B is a student sitting on the chair. How we define the function here? We define a function student sitting on the chair. Suppose this is your A and B, set A, set B. What indicates? A indicates A be the set of chairs, right? A be the set of say 40 chairs, 1, 2, 3 up to 40, and B be the set of 30 students, 1, 2, 3 up to 30, right? So this correspondence between set A to set B is a student sitting on the chair. It means every chair is occupied by the every students, right? This or chair occupied by every student. This is your function f, right? Now see, then the correspondence between A to B is a function or a mapping if and only if every student is sitting on a chair. This will be a mapping if and only if every student is sitting on a chair and no student is sitting on two different chairs. It means एक student कहीं पे भी sit नहीं कर सकता दो chair पे, right? No student will be sitting on a chair for a different chair. So no student sitting on two different chairs. So this will not become a function. If these conditions are satisfied, then f is called a function or mapping and is denoted by f defined from A to B, right? So here see, every chair every student is sitting on the chair. It means this function. So every element of B has a unique image in F, has a unique pre-image in A. So every student is sitting on the chair and no student is sitting on two different chairs. Okay, एक ही student दो different chair पे बैठ नहीं सकता. If these two conditions are satisfied, then the F is called as a function or mapping and is denoted by F defined from A to B. Okay, that is your function. Now let's see definition of a functions. Okay, so what will be the definition of a function? Now see here, let A and B be two non-empty sets. Then a function or mapping from the set A to set B is a rule which assign to each element A belongs to A to unique element B in B. Now see here, your A is any set, B is any set, both are non-empty, must be. Then we say that if it's a function from A to B with this condition, what is your condition? Suppose this is your set A and this is your function F from A to B. A and B both are non-empty. We say that, see, A to the mapping F from the set A to the set B is a rule which assigned to each element of A. Each element A in A, each element A in A to unique element B in B. It means every element of set A has unique image in set B. Means every element must have an image in set B. Okay, so the notation of denote that F maps A to B is F of A is equal to B. It means if you take here A, then F of A is equal to B. It means F operated elements of A, then that image goes to the elements of B. Then we defined F of A is equal to B, or AB belongs to F. Okay, now remark, F is well defined if F of A1 is equal to B, F of A1 is equal to B, and F of A1 is equal to C, which implies B is equal to C. Now this function will be well defined when F of A1 is equal to F of A1, which is equal to B is equal to C. Then if your function is well defined. Okay, now we will see that all that functions representation by diagrams. Now see, for example, here suppose F is a function, right? Suppose here we will see A be any set, A contains the elements, A1, A2 and A1, A2, A3, A4, okay? And B contains the elements here B1, B2, B3 and B4, right? So let S1 is equal to your, here let S1, suppose F defined from this, let S, this is your function, see, this is A and this is B, right? A contains A1, A2, A3 and A4 and B contains B1, B2, B3 and B4, right? So F of A1, yeah, so this is your function, okay? Every element has a unique image in P. So this is your function. Now next is S1. Suppose S1 is equal to 1, 2, 3, right? And S2 is equal to P, Q, R, S, right? So we will see here. Suppose this is your S1. Okay. Now this is your S2. Now see, here is 1, 2, 3. Here is P, Q, R, S. Now check whether this is function or not. Okay. See here, 1 has a unique image, that is P. 2 has unique image, that is R, and 3 has unique image, that is Q. It means every element of S1 has image in S2, right? This is your F. It means F of 1 is equal to P, F of 2 is equal to R, F of 3 is equal to Q. So every element has a unique image in S2. So F of S1, F defined from S1 to S2 f defined from S1 to S2 is a function. F defined S1 to S2 is a function. Okay, and it is also denoted by S1 to S2 by f. Okay, this is your function. But now we will see the next example in which suppose here a is equal to xyz and b is equal to 1 2 3 4 1 2 3 4 and the function is defined by xyz. Here is 1 2 3 4. Okay, and it is giving that okay. Now can you tell me this is a function or not? Is this a function? No, this is not a function. Why? Because as per our definition, every element has unique image. Okay, but here the x has two images, 1 and 2. Okay, so here every one element, suppose this is your a and b, so f defined from a to b is not a function. F defined from a to b is not a function because x is associated with because x is associated with two different elements, right? X is associated with two different elements, therefore f is not a function. Yeah, so as f defined from a to b is not a function because x is associated with two different elements. Okay, now next we will see the image and of a function. Now see here I elaborated this is a function because every element has a unique image, right? And this is one example where we will see here this is example 1 and this is your example 2 in which the element has every element has not unique. So here x is associated with two different elements, so f is not a function. Okay, now what do you mean by image of a function? If f is a function from a to b, that is f defined from a to b, then for f of a is equal to b, element b of b is element b of b is called f image of element a and element a is called pre-image of b, right? So here a is a is f of a is equal to b, element b of b is called image of element a of a and element a is called pre-image of b. See here f of a is equal to b is called image of a and a is called pre-image of b. Okay, it is your image of a function. Okay, now domain or codomain. Domain, codomain. So domain, codomain, it means here domain, it means the first element. If f is a function from a to b and f defined from a to b, then set a is known as a domain set and b set is known as codomain set. Okay, b is known as codomain set. See here, f defined from a to b. So we will operate f on every element of a. So A, B, C, X, Y, Z. So X, Y, Z, this is a set. So set of elements of all the elements of set A is known as domain and all the elements of set B is known as codomain. Okay, and range of a function. So range of a function, it means what? Every element of B is a range of a function. So range of f is equal to such that B belongs to B and f of A is equal to B. Then we say that B is known as a codomain. B is the, in other words, the range of A is the set of all images of the elements of A under F. So this is here. So range of A here, range of F is here, X, Y, Z. All the elements, all those elements which are in B, that is range of the elements of A. Okay. Now move further. Now let's see. Here. No, suppose your example. We'll take one example. Suppose here A is equal to XYZ, right? And B is equal to 1, 2, 3, 4, 5. So F defined from here. Okay, here F defined from A to B, right? Here X, Y, Z and 1, 2, 3, 4, 5, right? So what is the range of F? So if every element of B, that is suppose here X is Y, and T suppose. So this is the range of F. Let's see. These three elements is the range of F. Right? This is the element is a range of F. All these elements. It means 1, 2, 3 is the range of F. And the codomain is whole set B. Codomain. So there is a difference between range and codomain. So many people are saying that range of F and codomain are same. It is not always. Okay. This is the example where domain and codomain and range are different. Yeah. So here codomain and range are different. Now, now we'll see the next one. No, see. This is the example. If A is equal to -2, -1, 0, 1, 2 and F defined from A to R, where F is denoted by f of x is equal to x square plus 1. Find the range of F. Now we will find out the range of F here. See. So first of all, we will find out the all the elements. Okay, f of x. So we operate f. See, here is A. So it will be diagrammatically it will be more clear to you. So f defined from A to R. Okay. So this is set of real numbers. So first of all operate f x. X is equal to -2. So we will take here from right. So f of -2. So f of -2, how you define the function? X square plus 1. So here x square plus 1, it means -2 square plus 1. So -2 square is 4. 4 plus 1, 5. Okay. So here -2, here is 5. I will write down like this. Okay. Now f of -1. So -1 square plus 1. 1 plus 1, that is 2. So f of -1 is 2. Okay. Then f of 0. 0 square plus 1, that is 1, right? Now f of 1 is equal to 1 square plus 1, that is 2. Okay. F of 1 is 2. Now f of 2 is equal to 2 square plus 1, that is 4, plus 1, 5. So f of 2 is equal to again 5. So what is the range of this f? Okay, so range of f is all those elements. So 1 to 5. So range of f is equal to 1 to 5. I hope you are getting it clear. Range of f is equal to here 1 to 5. Right? Now, let's start next example. We'll go to the next example. Now see. Then let a is equal to 0, 1, 2, 3. Decide whether or not the following functions from a to a. If not, tell why. Okay, decide whether f is not a function from a to a and tell why. Okay, here is functions are given. Okay, f is equal to 0, 1, 1, 2, 2, 3, then 3, 0. Now tell me whether it is a function or not. Now if you want, you can draw the diagram so it will be more clear to you. Okay, a contains 0, 1, 2, 3 and a contains a. So both are same. 0, 1, 2, 3, 0, 1, 2, 3. So f of 0 to 1, right? F of 1, 2, f of 2, 3, f of 3, 0. Okay. So every image element has unique image. Yes. So this is a function. Yes. It is a function. It satisfies the definition of function. Every element has unique image. Right. Now second given function f is equal to. Here's second function f is given 1, 0. Go to the next page. That will be more better to you. Second one, f is equal to here given 1, 0, then 2, 1, then 3, 2, then 0, 3. Right? So you can draw the diagram. So it will give the more clear cut idea. A to B 1, 0, 1, 2, 3. So 1, 2, 3. Right? So 1, 2, 3. A to A function. So 1, 0, 1, 0, 2, 1, then 3, 2, and 0, 3. Yes, every element has unique image. So yes, it is a function. Yes, it is function. Right? Now third one. So f is given, f is equal to here 0, 1, then 1, 0, then 2, 1, then 3, 0. Right? So we will draw the diagram. So you can tell here directly also, but it will be more clear with the help of diagram. Right? So 0, 1, 2, 3. 0, 1, 2, 3. You can tell as it is also. See here, every element has unique image or not. 0, 1, 1, 0, 2, 1, right? 2, 1, 3, 0. So yes, it is a again function. Every element has unique image. Yes, it is a function, right? We'll go to the next example. Fourth one. You can see here fourth one. F is defined. F is equal to 1, 0, 0, 1, then 1, 2, then 0, 3. Right? So here D. So your function defined A to B. Here is A, here is B. Here 0, 1, 2, 3. Right? 0, 1, 2, 3. So F defined 1 to 0. 0 to 1. 1 to 2. And 0 to 3. So if you observe here, there is no image for 2 and 3. Okay. And one more thing, one element has two different images. So which is not a definition, which is not satisfies the definition of a function. Because to satisfy the definition of a function, every element must have unique image. Now here 0 and 1 have two different images. So this is not a function. Okay. No, it is not a function. Clear? Fifth one we will see. Here f is defined as f is equal to 1, 2 and 2, 3. Okay. A, this is B. 0, 1, 2, 3. 0, 1, 2, 3. Here A only. F is a function. There is also F. There is A. Now 1, 2, 2, 3. Yes, but it is not a function because every element is not having a unique image. Here 0 and 3 do not have any image. So this is not a function. No, it is not a function. It is not a function, right? It is not a function. So next is identity mapping. Okay, let A be any set and F be any function defined on set A. Right? A be any set and F be any function defined on set A. That is F defined from A to A. Right? A defined from A to A. F of x is equal to x. For all x belongs to A, then F is known as identity mapping or identity function and generally denoted by IA and identity mapping on set A. Right? So here A to A, F defined from A to A is a function and every element is having the same image. Suppose 1, 2, 3, 4. Here is 1, 2, 3, 4. So this is your identity element, identity mapping, right? From A to A. Every element has the same image. So it is identity mapping. Yeah. Now, next is constant function. The function is defined from set A to set B such that f of A is equal to B for all A in A. That is important. For all A in A, then f is called a constant function. In order to prove that f is a constant function, it is enough to show that range of f consists of only one element. Okay? So constant function, it means range of f is consists of only one element. Now we'll take one example. Suppose A is equal to, suppose here A is equal to 1, 2, 3, 4 and B is equal to xyz. B is equal to xyz. Then f defined from, here f is defined from A to B. Here 1, 2, 3, 4 and xyz. You can see the identity mapping. Suppose every element is maps to y. Okay. So f of 1 is equal to y, f of 2 is equal to y, f of 3 is equal to y, and f of 4 is equal to y. So every element maps to the one element. Okay, so and range of that element is only one element. So it is a constant function. Okay, every element maps to the one element only. So it is a constant function. Right? Now, types of functions or mapping. Now, we will see the types of functions or mappings. Here, one-to-one mapping. What do you mean by one-to-one mapping? Let's see here, one-to-one mapping. A function if defined from A to B is said to be one-to-one mapping or one-to-one correspondence, or also it is called as injective function or univalent function. Generally, we will use one-one and one-one and injective function. Okay, it is also called as univalent function. If for all a1 a2 belongs to A, f of a1, so a1 is not equal to a2, which implies a1 is equal to a2. Okay, here f of a1 is equal to, if a1 is not equal to a2, then f of a1, this is different. Here a1 is equal to a2. There must be a1 is equal to a2, which implies f of a1 is equal to f of a2. Now this is wrong. Here a1 is equal to a2, which implies f of a1 is also equal to f of a2. Or a1 is not equal to a2, then f of a1 is not equal to f of a2. Okay, So f of a1 is not equal to f of a2. If both the conditions are satisfied, then thus under this condition, the injective function on element of B can have at most one element of A as a pre-image. Only one pre-image is having for the every element of B. Okay, now see here. So this is not a one-one function, injective function. Why? Because this Y is having many pre-images, not only one. If there is only one pre-image, then it is injective function. Clear? Every element has a unique image and every element has a unique pre-image. Then only it is an injective function. Now this is a function but not injective function. Are you getting it? Now we will see one more example we have seen already. Now see. This is identity function is injective function. Every element has unique image and also unique pre-image, right? So this is not a function. Yes, this is an injective function. Every element has a unique pre-image. Yeah. So we can see here first unique image. Suppose here A is equal to, for example, here we can see A is equal to 1, 2, 3, 4 and B is equal to X, Y, Z, T, Q, right? A is equal to 1, 2, 3, 4, B is equal to X, Y, Z, T, Q. So here F defined from A to B. F defined from A to B. Here 1, 2, 3, 4 and here is X, Y, Z, T, Q. Right? So here you will get yes, this is a one-one mapping. Every element of A has a unique image and every element of and that element of B has a unique pre-image. So this is F is 1, 1. Okay. If there is no pre-image in Q, it is okay. That also it is a function and it is one function. Okay. Now next, many to one mapping, right? Many to one mapping. Then F is many to one mapping if A1 is not equal to A2, but F of A1 is equal to F of A2. It means the elements in A are not equal, but their images are equal. Then it is many to one mapping. Okay. So we'll see that many to one mapping function. For example, suppose A is equal to, here we'll see. Here suppose A is equal to 1, 2, 3, 4 and B is equal to X, Y, Z, T. Right? A is equal to 1, 2, 3, 4, B is equal to X, Y, Z, T. Then you will get here F defined from here A to B. Right? F defined from A to B, 1, 2, 3, 4, here X, Y, Z, T. Right? 1, 2, 3, 4, X, Y, Z, T. So you will get here. Suppose 1 is also. So this is many to one function. Here 1 is not equal to 2, but f of 1 is equal to y, f of 2 is equal to y. Right? So here this is an example of many to one function. Right? Next, into mapping. Into mapping. Into mapping it means if f defined from A to B, then f is into mapping from A to B if there exists at least one element in B which is not f image of any element of A. There exists at least one element in B where there is no in which is not an F image of any element of A. In this case, range of F is a proper subset of codomain of set. That is, F of A is a subset of B. Thus, in into mapping, at least one element of the codomain B is left uncovered by F image of the domain A. Okay, for example, that will be covered with the help of example. Suppose that A is equal to, here we'll take the same 1, 2, 3, 4 and B is equal to, here we'll see X, Y, Z, T, right? And F defined from A to B. Here is A, here is B. F defined from A to B, 1, 2, 3, 4. Here is X, Y, Z, T. right? So every element has. This is called as a into mapping. So one element is left here, at least one element, more than one element also can be left. So this is into mapping, right? As there does not exist any pre-image of T in A. There does not exist any pre-image of T in A. So this is your into mapping. Okay. Now next is onto mapping. A function f defined from A to B is said to be onto mapping if each element of B is the f image of at least one element of set A. In this case, range of f is a codomain set, that is f of A is equal to B. Right? In this case, range of f is codomain set B, that is f of A is equal to B. Now see, range of f is equal to codomain. Into में f of A is a subset of B, and onto में f of A is equal to B. Okay, so we'll take one example. Suppose A is equal to here 1, 2, 3, 4. Same example we will take. B is equal to xyz. Okay, and here f, there is A, here is B. F defined 1, 2, 3, 4 and xyz, right? F defined from 1, 2, 3, 4 to xyz. So here 1, 2, 3, 4 to xyz. See here 1 is having the unique image x, 2 is y, 3 is y, right? And 4 is to z, right? And 4 to z. Now see here, this is your onto mapping. It means if each element of B is the F image of at least one element of set B. This is onto mapping. It means every element of B has a unique pre-image in A. Then only it is onto mapping. We can't left any one element in that set B. Okay, which don't have a pre-image in A. So every element of B has a pre-image in A. That is your onto mapping. Now many one into mapping. Many one as well as into mapping. Okay, so how you can say that many one into mapping? If f defined from A to B is many one mapping and also f is into mapping, then f is said to be many one into mapping. Hence f is many one into mapping. If f of a1 is equal to f of a2, but a1 is not equal to a2, right? And second one, there exists at least one element in into mapping. It means there exists at least one element which don't have pre-image in A, right? So that is your into mapping. Now we'll see an example here. Suppose A is equal to A is equal to 1, 2, 3, 4. B is equal to XYZ PQ, right? So here A to B, right? So here 1, 2, 3, 4, and B is XYZ PQ, right? So see here. Hmm? Okay, it means there exists at least, this is many one and into. It means at least there exists at least one element which don't have pre-image in it. Okay, this is many one into mapping. Now how we can define many one onto mapping? If f defined from A to B is many one mapping and also f is onto mapping. Many one and onto, it means every element of B has a unique pre-image in B, A. Okay, so every element of B has a unique every element of B has a image pre-image in A. So suppose A is equal to, if you see 1, 2, 3, 4, right, and B is equal to suppose XYZ, right, F defined from A to B. 1, 2, 3, 4, X, Y, Z. Many one, right? And onto every element of B has a pre-image in A. Okay, this is your many one onto mapping. Now, 1 1 into mapping. 1 1 it means what? A1 is not A1 is equal to A2, then f of A1 is equal to f of A2. And if A1 is not equal to A2, then f of A1 is not equal to f of A2. That is your 1 1. And into mapping, it means what? There exists at least one element in B which don't have pre-image in A. Okay. So we'll see 1 1 and into mapping. Okay. First we'll write, for example, A is equal to, suppose 1 2 3 4. Right? And B is equal to A B C D. B is equal to A B C D E G. Right? So F defined from A to B. F defined from A to B. Here 1 2 3 4. And here is A B C D E G. Okay? A B C D E G. So this is your set B. As F is 1 1. Okay. So you will get 1 to E. Images we define 1 to E, 2 to B, 3 to C, and 4 to G. Right? So this is many one. Sorry, 1 1. Every element has a unique image. Right? F of A1 is not equal to A2, but F of A1 is equal. If A1 is not equal to A2, F of A1 is not equal to F of A2. So this is 1 1 mapping as well as into mapping. At least one element. D don't have pre-image in it. So this is many one into mapping. Okay, not many one, 1 1 into mapping. Sorry, 1 1 into mapping. 1 1 into mapping. Okay, next. 1 1 onto mapping or bisection. Both are 1 1 and onto. It means every element has f of a1 is equal to f of a2, then a1 is equal to a2. a1 is not equal to a2, then f of a1 is not equal to f of a2. And every element of B has a f image in A. So we'll see 1 1 onto mapping. Suppose A is equal to 1 2 3 and B is equal to, suppose, x y z. Right? F defined from A to B. A is 1 2 3, B is x y z, 1 y, 2 x, 3 z. So this is mainly here is 1 1 and onto mapping. 1 1 it means every element has unique image, and also every element of B has a pre-image in A. So 1 1 onto mapping. 1 1 onto mapping. Okay. Now next, inverse function mapping. If f defined from A to B is 1 1 onto, inverse exists only when if f is 1 1 and onto. It means bisection. Okay, if f is 1 1 as well as onto, then f is said to be bisective function. Then the mapping f inverse. Then the mapping f inverse defined from B to A. Then the mapping f inverse defined from B to A, which is associates to element B belongs to B to the unique element A in A, such that f of A is equal to B, is called the inverse of the mapping f defined from A to B. Now we'll see the mapping by diagrammatically. Okay. Now see, suppose this is your A and this is your B. F is a mapping from A to B, right? So here A, suppose, and here is B. Okay. Element A to B. Now F inverse is a Here is F inverse from B to A. F is from A to B. So F inverse of B is equal to A. Okay, and F of A is equal to B. Yeah, here F of A is equal to B and F inverse of B is equal to A. F inverse of B is equal to A. Yeah, this is your inverse function. F inverse of B is equal to A and F of A is equal to B. This is your inverse mapping. F defined from A to B and F inverse defined from B to A. Okay. Now, for example, suppose we'll see. Now let's composite of a functions or product of a functions. Composite functions or product of a function. We'll see. Let A, B, C be the three sets and let F be a function mapping from A to B. F be a mapping from A to B and G be a mapping from B to C. That is G defined from B to C. Okay. So we see that the G composite F is a mapping from G composite F is a mapping from A to C. Okay. G composite F is a mapping from A to C. We'll see diagrammatically here. Suppose this is your A. This is your set B. This is your set C. Right? There is A, B, and C. And F is a mapping from A to B. And G is a mapping from B to C. Right? Then G composite F is a mapping from F A to C. Okay. Suppose here A, here is B, here is C. So it means here G composite F we can apply is equal to G of F of A. But F of A is, it means what? You will get B. Right? This is your F of A is equal to B. So G of you will get B. But G of B, G operated on B, it will gives you C. So G composite F of A is equal to C. Okay. So this is your mapping from A defined from A, F defined from A to B, G defined from B to C, then G composite F defined from A to C. Yeah, this is product of functions or composite of a function. We also called as it is a composite of a function. Okay. Now, it is given that the three functions f, g, h are defined from R to R as follows. Okay. F of x is equal to 2x cubed plus 5. G of x is equal to cos x. H of x is equal to x cubed minus 1. Then find H composite G composite F and H composite G composite F. Are they equal? That we will see. Okay. So first of all, we'll write here f of x is equal to 2x cube plus 5. G of x is equal to cos x and h of x is equal to x cube minus 1. Okay. Want to find out H composite G composite F. Okay. So we'll operate on x. So we'll get H composite G composite F of x. Right. So which is equal to H composite G of F of x. Right. Now G of F of x, it means H composite here. G of F of x, it means what? 2x cube plus 5. Right. Now treat this as your x. So H composite G of x, it means cos of x. So cos of 2x cube plus 5. Right. Now H composite x. So H of this. So you will get H of, is it nothing but, can we write this as same? Right. Okay. Now this is your x for h. So h of x is equal to what? Cos cube x cos cube of 2x cube plus 5 minus 1. Right? This is called equation number 1. So we'll see that second one, H composite G is composite G of X. Okay, composite of F of X. So here H of, first of all, we will get H composite G of F of X, but F of X is 2x cube plus 5, right? And then here is H of G of X, 2x cube plus 5, right? But G of X is what? Cos X. So you will get cos of 2x cube plus 5. Okay. So here H of this, H of X, it means cos cube of 2x cube plus 5 minus 1. Now this is your equation number 2. Now see the equation 1 and equation 2. Both are same? Yes. Yes. So therefore H composite G composite F of X is equal to H composite G composite F of X are equal, right? Or we don't operate on X directly, we can say that these two are equal. So composite functions satisfy the associative property. Okay, composite functions satisfy associative property. Composite functions satisfy the associative property. Okay, now next is, we'll see the next example. Let the function f and g be defined by f of x is equal to 2x plus 1 and g of x is equal to x square minus 2 respectively. Find g composite f of 4 and f composite g of 4. So first of all, we will calculate g composite f of x and then we'll put x is equal to 4. So g of f of x. So what is your f of x? F of x is 2x plus 1. And what is g of x? So g of x is, okay, here also we can directly put the value of g of x is equal to 4. It will be more simple. 2 into 4 plus 1. So here is g of 9, right? G of 9. So g of 9 is equal to 9 square. 81 minus 2, 79. If composite g of 4, g composite f of 4 is equal to 79, right? And f composite g of 4, that we will find out, f composite g of 4 is equal to f of g of 4, right? So f of g of 4 is what? 79 of 4 sorry, not 79, 4 square. 4 square is 16 minus 2, 14. F of 14. So here f of 14 is equal to what? 28 plus 1, 29. So G composite F and F composite G. So F composite G of 4 is equal to 49. Now G composite F of A plus 2. Second or third. G composite F of A plus 2. We will get G of F of A plus 2. So what is your f of x? F of x is 2x plus 1. So instead of x, into a plus 2 plus 1. Right? Then you will get g of 2a plus 4 plus 1. So g of 2a plus 5. What is your g of x? G of x is x square minus 2. So here you will get 2a plus 5 square minus 2. This will gives you 4a square plus 20a plus 25 minus 2. So is it nothing but 4a square plus 20a plus 23, right? So G composite A of 2. Now that second one, F composite, third one, no? F composite G of A plus 2. Here, F composite G of A plus 2. So, which is equal to F of G of A plus 2. So, F of G of A plus 2, it means what? A plus 2 bracket square minus 2. F of A square plus 4A plus 4 minus 2. Right? So, here F of A square plus 4A plus 2. What is your F of X? F of X is 2x plus 1. So 2 into A square plus 4A plus 2 plus 1. Right? So you will get 2A square plus 8A plus 4 plus 1, which is equal to 2A square plus 8A plus 5. Hope you are getting it clear. Now, represent the given function in a graphical, tabular, and matrix form. F is given. Here F is given graphical, tabular, and matrix form. So graphical representation, as we know that. First one, graphical, right? There is 1, 2, 3, 4, 5. And here is again, can say 1, 2, 3, 4, 5. 1, 3. 1, 3, 2, 5. 3, 5. 4, 2. And 5, 3. Okay? This graphical representation here A to A. And next is tabular form. In tabular form, that we can see F 1, 3, 4, 5. One, 2, 3, 4, 5. Right? Now here tabular form is 1 related to 3. Yes. Then 2 related to 5. Yes. Then 3 related to 5. Yes. 4 related to 2. And 5 related to 3. This is your tabular form. Okay. Third one, matrix form. Matrix form. Okay. Zero. 0. 1 related to 3. 0, 0. Related to 5. So 1. Otherwise it is 3 related to 5. Otherwise it is 4 related to 2. Otherwise it is C. And 5 related to 3. Otherwise it is C. Your matrix form. Very simple. Now let f of x is equal to x plus 2. Q of x is equal to x minus 2. H of x is equal to 3x for x belongs to R, where R is the set of real numbers. Find G composite f. Okay. Much we have to calculate G composite f of x is equal to G of f of x is equal to G of f of x plus 2, and g of x is equal to x minus 2. So x plus 2 minus 2, which is equal to x. Okay. Second one we will see f composite g of x. So f of g of x. So f of g of x is x minus 2 and f of x is x plus 2. So x minus 2 plus 2 is equal to x. Third one, right? Third one is here f composite f. So f of x. f of x is x minus x plus 2. f of x plus 2 is x plus 2 plus 2. So x plus 4. Fourth one, h composite g of x. So h of g of x. So h of g of x is x minus 2. h of x is 3x. So 3 into x minus 2. So 3x minus 6. Right? Fifth one, decomposite g of x. So g of x. g of x is x minus 2. So x minus 2 minus 2. x minus 6. F composite h of x. f of h of x is equal to f of h of x is what? 3x. Right? And f of x is x plus 2. 3x plus 2. Seventh one. One is h composite f. So here h composite f of x. h of f of x equal to h of f of x is x plus 2 and h of x is 3 into x plus 2 equal to 3x plus 6. Eighth one, f composite h composite g of x. So f of h of g of x. Right? So f of h of g of x is g of x is x minus 2. Right? h of x minus 2 is 3 into x minus 2. Of 3x minus 6. So f of x is x plus 2. X minus 4. Yeah. And next composite h composite that. Next we see next lecture we will see the countable sets, uncountable sets, and then the enumerable sets, then discrete numeric function, pigeonhole principle, everything we will see in the next lecture. So I hope you are getting it clear how to find out the function and different types of functions, definition of a function, whether it is function or not. Okay, everything will be clear to you here. I hope it is totally clear to you the definition of function, different types of functions, then the examples depending on the function. So if you are liking my videos, please do like, share and subscribe. Thank you so much. I will be here tomorrow at the same time with a new topic, that is countable and uncountable set and with discrete numeric function.